Hello everyone. Today we will continue lecture 6 about the discrete random variables and probability distributions. Today we are going to learn hypergeometric distribution and Poisson distribution. We are in the second part of discrete probability distribution in hypergeometric distribution. Here is a formula for hypergeometric distribution. As you see in denominator, we write combination nn. This is n. This n here represent number of population, number of elements in the population. A represent number of success in the population. This capital A. Small letter case n represent sample size, and x represent number of success in the sample. In order to understand this formula and how it's worked, let's consider this simple example. Suppose that we have 20 balls. We will take it as population. Automatically n equal to 20. Suppose that 5 of these 20 balls white and the rest black. Okay. As A, you may take 15, the number of black balls in the population, or 5, number of white balls in the population. It's depend on situation. Okay. Now, suppose that out of these 20 balls, we randomly select 7 balls. Okay. Automatically n equal to smaller case of letter n equal to 7. And the question, this is important part. What is probability of selecting out of 7 balls, selecting 2 balls being black? Automatically, if in the sample we talk about black balls, 2 black balls exactly in the sample, then x equal to 2, and because x here we understand that represent the number of black balls, A you should take as black balls, 15 balls. So n 20, A 15, smaller case of letter n, which represent the sample size, selecting samples, selecting several balls. This is 7 and x is 2. You should know that A you determine only after x, okay? That's all. And here is a formula for it. As you see in denominator, we write combination nn. How many possibilities for selecting n balls out of capital N balls, okay? In our example, it's 20 here, 7 here. We have 15 black balls, so A 15 here. We have in the sample 2 black balls, so x is 2. N minus A represent the number of white balls. If you have 15 black balls, automatically this will give you 5 number of white balls. And n minus x represent number of white balls in the sample. Number of white balls in the sample. Okay. In our current question, because n equal to 7 and x equal to 2, 7 minus 2 give us 5. It means that number of white balls we consider here as 5. And here just the formulas for combination, we open it. And no need for learning this. Learn just this part, and by using it you can solve any question. Now let's consider one example about hypergeometric distribution. Suppose that 3 different computers are checked from 10. 4 of 10 computers in this department have illegal software loaded. What is the probability that 2 of 3 selected computers have illegal software loaded? Here 10 represent the number of all computers. That's why automatically capital N, which represent the number of all computers, number of population, N equal to 10. Here, as you see, they select 3 computers, and what is the probability? 2 of them has illegal software loaded. So, N, which represent the sample size, equal to 3, and X, which represent the success in the sample, in this case is number of illegal software loaded computers in the sample, it's 2. So, as capital A here, we should take 4, which represent the illegal software loaded computers out of all 10 computers. So you have N 10, capital N 10, smaller case of letter N 3, A4, X2, and just plug in into the formula and you get the result 0.3. And what does it mean? It means that if we check this situation, the probability of obtaining or finding 2 computers which have illegal software out of 3 equal to 30%. The probability that 2 of 3 selected computers have illegal software loaded is 30%. Let's consider example. The factory which produce skyboards buy 100 lithium-ion batteries each time. In order to check that battery is okay or not, they select randomly 6. If 2 or more batteries are improper, they check all of 100 batteries. What is the probability that all 100 batteries will be checked if the number of improper batteries among 100 is 25, 30, 5, and 10? Here, students, you should know that 100 here represent the capital N. This is number of batteries which they have for each case. They select 6 of them. That's why smaller case of letter N is 6. They say, if out of the 6 batteries, 2 or more improper, if 2 or more batteries are improper, then they check all 100 batteries. To check all 100 batteries, it's time wasting process. That's why they don't want to do this. So in order to check and to trust that all 100 batteries work or not, they randomly select 6 of them. There is a rule here. If 2 or more of them is improper, they will check all 100 batteries. If the improper batteries less than 2, that is 1, or improper batteries 0 out of 6, they will not check the all 100 batteries. Maybe this is a accepted situation for them. Okay, here X more than or equal to 2, this represents number of improper batteries in the sample. And here 25, 35, 10, these numbers represent for each case the number of improper batteries in the population, in the big set. Okay, you should take for A, if you want to solve A, instead of A, 25, instead of capital N, 100, X more than or equal to 2, and smaller case of letter N is 6. For this case, similarly, just you will change the value of A. A is 30 in this case. In this case, A is 5, and here 10. Discuss the difference in your result depending on the number of improper batteries in 100. We will understand after calculation, okay? what will happen if the number of improper batteries in this population is 30 or 5 or 10 or 25. Let's look to the solution. For the first A, you see N6, A25, capital N 100. In order to find the probability that x greater than or equal to 2, you may find probability of x equal to 0 plus probability of x equal to 1, and from 1 you can subtract this 2. Automatically you will obtain this probability. But if you want to do this in hard way, you should find the probability of 2, 3, 4, 5, and 6. 5 numbers, and then add all of them. But this is shortcut way. Here you will need just to calculate two things, 0 and 1. You see, this is another representation of combination. Combination 25, 0 for x0. Combination 100 minus 25 and 6 minus 0. And in the denominator, combination 106. We obtain here some result and we add to this x equal to 1. The answer here 0.4691. In B part, they say the probability, find the probability that in the 100 batteries, 30 improper. We select 6, number of improper batteries in the population 30, number of population 100. Again, we want to find the probability of the same situation. So again, we will subtract from 1 these two probabilities. And we obtain, in this case, answer 0.58. Close to 0.59. Here, 0.47. This is solution of C part. As you see here, N6, A5, and capital N 100. Again, the probability of this situation. We calculate the answer 0.02. And for A10, answer 0.1. You see, answers completely different. Look at this. Here, the probability of having this situation is higher. Here, too high, approximately 60% of happening this situation. This 47. And this situation is very small. Because why this happening? Because the number of improper batteries out of 100 is too small. Just 5 out of 100. The probability that on your selected 6 batteries you will have at least 2 of them is a very small number. Just something like a 3%. Here 10, that's why a little bit bigger than this, 0.11. And in the previous two, it's too high. See, here it's highest because A is 30. That's all about this question. Now let's talk about Poisson distribution. We apply Poisson distribution when you wish to count the number of times an event occurs in a given continuous interval. The probability that event occur in one subinterval is very small and is the same for all subintervals. It means that probability of happening something inside of interval evenly distributed. Everywhere probability the same thing. The probability of event that occur in one subinterval is independent of the number of events occur in the other subintervals. Okay. And the third, there can be no more than one occurrence in each subinterval. And the last important thing is that the average number of events per unit is lambda. I know that for you to check these things a little bit hard. That's why in the question about Poisson distribution, we will give you some clue that you can apply here Poisson distribution or not. And the important parameter for you for the question is lambda, which represent the average number of events per unit. Remember, this is important thing for this distribution. Here is formula for Poisson distribution. As you see, we have a fraction here. In denominator, we write x factorial, which represents the number of successes per unit, this is something which you want to find. Lambda, expected number of successes per unit. This is always given in the question. Before starting calculating this probability, it's given. Should be given, okay? And the e here represent the base of natural logarithm. Approximate value is 2.7. Okay, as you see, e we raise to the power negative lambda multiplied to lambda to the power x divided by x factorial. Poisson distribution characteristic: the mean equal to lambda, variance also equal to lambda, standard deviation equal to square root of lambda. We may find these formulas using the formula for expected value and the formula for the variance. It's not hard, but you need to remember these three things: expected value, variance, and standard deviation for the Poisson distribution. For the binomial distribution, we learn to use the table for calculation and the formula. For hypergeometric distribution, there is no table. We just use their formula. For Poisson distribution, again, we have a table. And now let's take one example and explain how we find out the probability using a table. In Poisson distribution, as we told before, we have just two parameters: x, which is represent the number of events occur in 1 unit, and this lambda is expected number of points, number of events happening in 1 unit. But this is average. That's why don't say why this is 0.5, why something happening 0.5 times. This is average time of happening. That's why it's can be different than integer number. Using the formula, you just plug here instead of lambda 0.5 and instead of x 2. And in the table, you have the similar thing. You have values for lambda started from 0.1 till 0.90. This is the part of table, of course. It's not all of it. And x values starting from 0 goes to positive infinity. But when x goes to the infinity, starting from 0, all probabilities here are close to 0. That's why table ends at 7. Okay, they don't write anything after 7. But remember that after 7, it comes here 0. The numbers very close to 0. That's why you may take them as 0. Okay, because x2, we select here x2, lambda 0.5, and intersection, you see approximately same result. Now let's learn how to use this table. x8, lambda 1.7. You should find first lambda because we have x everywhere. Lambda is important. Lambda 1.7 here. And for x8, find intersection, you get this value. X less than 3, lambda 2.3. The number of occurrence in one interval cannot be less than 0. At least it's 0. That's why in order to find out this thing, you may add for lambda 2.3 the values for x 0, 1, and 2. It's discrete distribution. That's why you should take only discrete values 0, 1, 2. And add up these probabilities. You obtain this answer. You may use the formula. You will get the same result for sure. C part. X greater than 8. Lambda 4. Where's lambda 4 here? 8 we have approximately here. You should know more than 8, therefore you should take 9 and over 9. So this, and this. But after these numbers, here we have just 0. So the probability of this thing, if you want to find, just add up these probabilities. X more than or equal to 8, lambda 3.1. In this case, you should take 8 and the numbers after 8. This, and this. As you see, 14, 13 here, you may take as 0. E part, x less than or equal to 1, lambda 0.5, x less than or equal to 1. So you should take just these two numbers. Let's consider in a Poisson distribution with double inequality. X between 5 and 9, lambda 5.4. 5.4 here. Between 5 and 9, it means that you should add 6, 7, and 8. These three numbers. You get this answer. 11, 12, 13, 14 for lambda 4.1. These numbers you should add, you obtain this answer. 11, 13, 14 for lambda average number of event per unit. This answer, this part, these probabilities you should add. And for D part, 12 and 13, just two numbers for lambda 6.3. Yes, just these two numbers, and the answer 0.0223. Let's consider example about application of Poisson distribution. Assume that the number of network errors experienced in a day on a local area network is distributed as a Poisson random variable. The number of network errors experienced in a day approximately 2.4. This is average number of network errors, okay? 2.4. This automatically represents the lambda because they say the mean number of network errors or the average number of network errors. This is 2.4. Why it's not an integer number, we already explained it to you, because to find this number you should add the number of errors in all days and divide by number of days. So it's possible that it's not integer number. That's why it's possible. What is the probability that in a given day 0 network errors will occur, exactly 1 network errors will occur, 2 or more network errors will occur, fewer than 3 network errors will occur. 0 network, it means x is a 0, exactly 1, x is 1, 2 or more, x greater than or equal to 2, fewer than 3, it means that x less than 3. Okay, let's consider solution. For x0, lambda 2.4, you may use your formula and get this result. For x1, for x more than or equal to 2, you cannot find this just by using the formula, because for x values start from 0 goes to positive infinity. You cannot add infinitely many numbers. For this reason, you need to go to the complement event. X less than 2 is complement event for this, and from 1 you can subtract this. For x less than 2, it means probability x equal to 0 and probability x equal to 1. x0 is this, x1 is this. So answer is this number. For x less than 3, you should add probability of x0, x1, and x2. You obtain this result. If you want, you may find all this result from the table also. As you see, x0, we have this. x1, we have this. x more than or equal to 2, you should add all these numbers here, but you have the simple way, just from 1 subtract these two numbers, you obtain the same result. X less than 3, add up these three numbers. That's all. In this lecture, we explained to you discrete random variables and probability distributions, binomial distribution, hypergeometric distribution, and Poisson distribution.